Okay, guys, so we are back with the next section called special right triangles. Now, this section is going to, it's going to focus on right triangles, obviously. There's only two that we consider to be special right triangles. They have some unique patterns in the relationships among the sides, but it's going to heavily rely on our ability to work with radicals. Everything in this section uses radicals. So that's really important. Let's jump right into it. There are two special right triangles that we're going to focus on, the 45-45-90 and the 30-60-90. Now, they are named that because of their angle measurements. So our first triangle is a right triangle, the 90, and the two acute angles are 45 and 45. So this is a right isosceles. Keep that in mind. It means the two legs are congruent. The second one, again, a right triangle, but our two acute angles measure 30 and 60. So this is definitely a right scalene. Um, so let's get started here. And we're going to start with the 45-45-90. But what I want to show you, and this may not be 100% clear, this is clipped right from a textbook. This is how the rules for these are presented in a textbook. What they're really showing you is just the relationship among the sides. And I'm going to break this down. I'm going to make this a lot more clear. But this is coming straight from a textbook. I'm going to show it to you a couple different ways so that way you can approach it in the manner that best suits you. So let's start with the 45-45-90. We're not going to do the discovery part of it. We're going to jump right into it. I'm showing in this slide, I'm actually showing you the same thing three different ways. So let me just kind of break this down. This is the textbook. Right? This is what every textbook shows you. And that's fine once you understand it. What I did was I broke this into two other formats. This kind of map where we just follow the arrows. I don't know what else to call it. And a formula. That one's pretty straightforward, just a formula. Now you can use either of these. Um, it does not matter. They all say the exact same thing. Sometimes it's a little bit easier to see as a formula or as a map than that textbook graphic. But they're all saying the same thing. So I'm not giving you a lot of different things here. I'm giving you the same thing in three different formats. And now it's your choice what suits you the best for learning purposes. So let's understand it. Let's look at the formula first. I think that's usually the most straightforward. It says in a 45-45-90 triangle, the hypotenuse equals the leg times square root 2. Simple mathematical formula. Fill in one variable, find the other. Hypotenuse equals leg times square root 2. Now, the legs are congruent. It's an isosceles triangle. So it doesn't matter which leg we're talking about. The hypotenuse equals a leg times square root 2. That's all it means. So now that we understand that formula, look at the textbook graphic. Both legs are marked with X. Well, that makes sense because it's an isosceles triangle. The legs are congruent. For the hypotenuse, it says x square root 2. Well, that means x times square root 2. So the hypotenuse is the leg, which they marked as x. So the leg times square root 2. X times square root 2. Now, that does not mean every measurement for the hypotenuse will end in square root 2. It is a formula. Take whatever there is for the leg and multiply by square root 2. They're just showing it to you in this graphic form that shows the relationship among the three sides. Now, the other thing I did was kind of break that formula into a map. Obviously, if we know the hypotenuse, if we know the leg, we're going to plug it in and multiply by square root 2. If we know the hypotenuse, we would have to divide by square root 2 to get the leg variable by itself. And that's all I'm showing you in the map. Effectively, for the use of the map, put your finger on, identify which is given. It's either the hypotenuse or the leg. Put your finger on it and follow the arrow. There's only one way to go. If you know the leg, you're going to multiply by square root 2 to get the hypotenuse. If you know the hypotenuse, you're going to divide by square root 2 to get the leg. So again, I think the formula is straightforward enough, but I definitely want you to relate that formula to what that graphic is showing you, because whenever you look this up, a textbook is always going to show that graphic, and we need to understand what it means. Applying it is as simple as use that formula. 45, 45, 90, hypotenuse equals leg times square root 2. So let's just look at an example or two. There's not much else to do with this. Let's see. I'm gonna start with B. I don't know why it printed like that, but let's do B. Identify the parts. Leg, hypotenuse. We have one formula. Hypotenuse equals leg times square root 2. We're looking for the hypotenuse. The leg they gave us is 9 square root 2, and we're going to multiply by 9 square root 2. Well, that's 9 square root 4, which is 9 times 2, which is 18. So x is 18, and x in this case is the hypotenuse. So our hypotenuse equals 18. That's it. We're just figuring out what to do here. For question D, let's do question D, and I'll bring it out here. Again, we're looking for the leg. Now, even though they marked them both, the legs are congruent. So once we find one, we know the other. Hypotenuse. Hypotenuse equals leg square root 2. The hypotenuse in this question is 8 square root 2. The leg is x times square root 2. So to get x by itself, we have to divide by square root 2. And square root 2 over square root 2 cancels, and we're left with 8. So both legs are 8. Now, the work with the radicals is going to be more complicated, which is why we reviewed radicals first. But the new learning element here is for a 45, 45, 90, the hypotenuse equals the leg times square root 2. Whatever you have to do to work out your radicals depends on the question. And that's going to change in every question. Now that brings us to a 30, 60, 90. And again, I'm not going to go through the discovery. Let's just jump to it. Just like before, I'm giving you the same information in 3 different formats. The textbook, a little map that you could just follow the arrows, and formulas. So it's the same information, 3 different formats. Let's look at the formula. The formula looks pretty straightforward. In our triangle, remember, it's scalene. So all 3 sides are different. 30, 60, 90, 3 different angles, 3 different sides. So it's a scalene triangle. We have the hypotenuse, and then we have the 2 legs. But the legs are different. So one is shorter, one is longer. One is short, one is long. And that's what I'm using in my formula. This is how I think about it. I have a shorter leg and a longer leg. So again, you can kind of see how these formulas play out. Hypotenuse is the short leg times 2. Well, we have to know which is the short leg and which is the long leg. I'm going to talk about that in just a second. The long leg, and I'm just abbreviating, equals the short leg times square root 3. Again, each formula has two variables. You plug in one, and then you do your algebra, you work with your radicals, and you get the other. That's as tough as the formula is. So far, the big challenge is how do we know which is the short leg and which is the long leg? Well, there's a simple way to do that. The longer leg is opposite the bigger angle. So we have some very simple relationships in triangles. So I'm just going to summarize it right here. The biggest side is opposite the biggest angle. The smallest side is opposite the small angle. So if we think about our triangle, and this is true for all triangles, not just 30, 60, 90, we already know that the right angle, that's the biggest angle, is opposite the hypotenuse, which is the longest side. Well, look at the two angles that are left over. 30 is the smallest angle. So this is the small or the short leg. $60, this is going to be the longest leg. The smaller angle is opposite the smaller side. So call that the small leg or the short leg, whatever works for you. These are my terms because they work for me, and I think they're very simple to understand. Short versus long. One of them shorter, one of them is longer. Which is which? They're opposite the small angle or the big angle. Short and long angle doesn't make sense. So we have to kind of use some sensible terminology. The biggest side is opposite the bigger angle. The smaller side is opposite the smaller angle. So the smaller leg is opposite the smaller angle, the 30. The bigger leg is opposite the bigger angle, 60. Maybe small leg and big leg work better for you. So rewrite it, substituting those words. Small leg and big leg instead of short leg and long leg. That's, how you can take your own notes and make this better for you. Now, the textbook image, just like before, is showing a relationship. So look at it opposite the 30. At the bottom is x. Well, that's the smaller or shorter leg. The hypotenuse says 2x. 2 times x, 2 times the shorter leg. Same as my formula. So again, I'm getting my formula from that graphic to help us understand what that graphic is telling us. That longer leg, which is opposite the 60, is the short leg times square root 3. And then I have my little map version, which is simply, what do you have? Follow an arrow. So if the question gave you the hypotenuse, the only thing you can do is divide by 2 to get the short leg. Whether the question asked for it or not does not matter. That's the only thing you can do. But once you have the short leg, then you can follow the arrow to the long leg if that's what you were looking for. So again, you might have to do 2 steps. Those are your formulas. Those are your only formulas. If you were given the hypotenuse, the only thing you can do is get the short leg. And if that's not what you want, then there's a second step. But sometimes you're just stuck. That's all you can do with the formulas you have. It just means there's more than one step. So let's look at a couple examples. And again, we're going to keep these two formulas or relationships in mind. The hypotenuse equals the short leg times 2. The long leg equals the short leg times square root 3. And let's see what we have going on here. Let's do A right here. The first thing I need to do is identify my three sides. So obviously we have the hypotenuse. Since my 30, this is my short leg or my small leg, whatever you want to call it, which means this is my longer leg. Now I'm looking for two things. I'm going to do x first. That's the hypotenuse. So I'm going to use hypotenuse equals short leg times 2. That's x equals 5 square root 3 times 2. And I get 10 square root 3. So that was the first part. The second part of the problem is looking for y, the long leg. So I'm going to use the other formula. The long leg equals the short leg times square root 3. The long leg is y. The short leg is 5 square root 3. And I'm multiplying by square root 3. That's 5 square root 9, which is 5 times 3, and y equals 15. Okay. Let's take a look at another example here. Let's do question B. Bring it out here. Again, identify the parts that we're working with. We have the hypotenuse from the 30, the short leg, and makes that the long leg. So I have the hypotenuse. I have to use the hypotenuse formula. I don't have any choice at all. So whether it's x or y, whether I want it or not, I have to get that short leg. I have to. Even if the question did not ask for it, that's the only thing I can find from this formula. Because I know the hypotenuse, the only thing I can do is find that short leg. I'm going to divide by 2, and that short leg equals 4. Now I can go ahead and get that longer leg. So the next thing I'm going to do is get that longer leg. If there was no x for the short leg, this would still be my work because I have no choice. The longer leg is the short leg times square root 3. So they gave me a y. I now know the short leg times square root 3. So y equals 4 square root 3. Once I know the value for the short leg, I plug it in for short leg. And that is it. And again, like I said before, the complexity of the work with the radicals, different in every question. That's why we've been working with radicals, and that's why we reviewed it right before this unit. But the formulas, how and when to use them, that's the new piece. All right, so let's do some practice with that and build our skills.